Hello everyone, welcome to my channel. In this video we are to evaluate this integral without actually performing integration. Now how is it done? Here is the approach. So we have the integral from 0 up to 1 of t times the square root of 1 minus t to the power 4 dt. Let's call this page 1. So we rewrite this integral as follows. This is the same as the integral from 0 up to 1 of t times the square root of, watch what I do inside there, 1 minus t squared, and we raise this to the power 2. You can see there by using laws of exponents, multiply the 2 out, you get 4 dt. Now I'm going to combine t with dt in my next step. So this is the same as the integral from 0 up to 1 of the square root of 1 minus t to the power 2 raised to the power 2 times t dt. Nice. Now I'm going to perform what we call use substitution, but I'm going to use x for some reason. You'll understand a bit later. So we're going to let, at this point, x be equal to t squared, that one there. Now, this is the first step. I'm going to perform differentiation on both sides. dx is equal to 2t dt, but I have t dt there. So I'm going to have to divide both sides by 2. So I get dx all over 2. The answer is t dt. Nice. Now this part is taken care of, that part is taken care of. I have to work on the limits now. So this is bulletin number 1. This is what we do. The second part, we move on to the limits. Let me squeeze it in here. Limits. So we are saying now, as t approaches 0, what does the x approach? We use this equation here. X must approach 0 squared, and we know that this is 0. That's the lower limit. So lower limit doesn't change. Let's look at the upper limit. And as t approaches, what is the upper limit? 1. What does x approach? X must approach, we're back here, 1 squared, and 1 squared is 1. So limits of integration do not actually change. Now, therefore, this integral is transformed as follows. Moving on to the next page and just complete this one. Now, that integral is transformed as follows. So we now are going to say that the integral there is going to be equal to the integral from 0 up to 1. Remember, limits of integration do not change. Of 1 minus now t squared, this t squared raised to power 2, we put x here, it will be x squared. So that will be x squared. And outside here, instead of having t dt, I'm going to have dx over 2. dx over 2. Let's call this page 2. Now take half out because it's a constant. 1 over 2 times the integral from 0 up to 1 of the square root of 1 minus x squared dx. At this point, I want to remind you, remember the idea is to evaluate this integral without integrating. At this point, I would like to remind you of the equation of a circle, x squared plus y squared equals 1. This is a circle, you say why 1? Because we have 1 here. And if you solve for y squared here, you're going to get y squared equals 1 minus x squared. There is the expression we're dealing with, that one there. And if you take square both sides, you're going to get y equals plus or minus the square root of 1 minus x squared. So now, this tells you that you have a circle of radius 1, center 0, 0, radius 1. So we have 1 here, there, minus 1, and obviously the center is 0, 0 there. This will be your x-axis, and that will be your y-axis. Now, understand something. The plus sign is for the upper part. If you allow me to use a different marker here, or maybe a red one, probably, if it works, we are saying that top part there, that top part is represented by y is equal to positive square root of 1 minus x squared. The bottom part will be the minus 1. So the bottom part here, this one here, is your y is equal to negative the square root of 1 minus x squared. So therefore, this integral is basically telling us, we're talking about this integral from here up to there. It's telling us that we're interested in this area here, which is area of a quarter circle of radius 1. So let's work out area of this, and then we'll put it here. We're done with our integration. So area of that quarter circle, you agree with me that we're simply going to say shaded area is page 3 is just going to be equal to a quarter of pi r squared. But what is this? This is a quarter of pi r. Remember, radius is 1. We square it, and the answer is pi over 4. Now we bring pi over 4 in that space, and then we're done. So we're saying, therefore, the integral from 0 up to 1 of t times the square root of 1 minus t to the power 4 dt is just going to be equal to, remember, half. We're here, half of that, and that evaluates to pi by 4. So this is going to be half of pi by 4. You agree with me, the answer is just pi by 8. Now I invite you to evaluate this integral by using the traditional approach of evaluating integrals. Evaluate this integral, and you should come up with that as your final solution, which is pi over 8. All right, this is where I'm going to stop. We were evaluating this integral without actually integrating. As you have seen, we have not performed integration here. We simply used the idea that looking at this part here, we remember that the equation of a circle of radius 1 centered at 0, 0 is given by that. And solving for y, we obtained the upper part, which is basically that integrand there. Understanding that from 0 up to 1, we're integrating from 0 here at the origin all the way up to 1 there. That's why I shaded that part. Integration from 0 up to 1 is just area of this here, a quarter circle. And remember, radius is 1. So we went on to evaluate that. And putting back here, that expression gives us the ultimate solution to our integral. All right, I'm going to stop here. See you in the next one.